You know, every few years, a moment comes along that feels like a real turning point. It's when all the buzzwords and all the promises from the labs suddenly start to show up in the real world, in our hands, in our homes, and in the very infrastructure that powers our lives. Well, it really looks like 2026 is shaping up to be one of those moments. Okay, let's dive right into this.
So what's the big deal about 2026? What makes this year so special? Well, what we're seeing is this incredible convergence of technologies that have been in the works for years, and they're all hitting a critical point at the exact same time. This isn't just about another new iPhone. It's about a fundamental shift in what our technology can actually do.
For a long time now, these technologies have just been bubbling up in labs and in small pilot programs. But now, we're hitting what the experts are calling a decisive phase. They're finally breaking out and becoming the mainstream infrastructure we're all going to rely on. And you can see it everywhere, from the AI in your pocket to the power grid that keeps it charged.
And this whole shift is changing how we even think about progress. I mean, for decades, it was all about Moore's Law, right? Just making computer chips smaller and faster. But we're kind of hitting the physical limits of that whole approach. So in 2026, the real frontier is something called system-level performance. It's not just about the chip anymore. It's about how well the chips, the memory, and the packaging all work together as one single seamless unit.
But here's the catch. With all this incredible new power comes an equally incredible new risk. It's a hidden threat from computers that don't even fully exist yet, but their shadow is already looming over all of our secure data. And it's a challenge that has to be solved right now, before it's too late.
All right, so let's start our journey where this future feels the most real, right in the palm of your hand. The smartphone is pretty much the command center of our lives, and in 2026, it is getting a whole lot smarter.
What's so fascinating here is how two totally different phones are actually telling the same story. On one hand, you've got the Samsung Galaxy S26 Ultra for the mainstream user, and on the other, you have the Red Magic 11 Pro, an absolute beast built for gamers. They actually share the same powerful Snapdragon chip, but they use it in completely different ways. Samsung is focused on a privacy display to block nosy people, which, let's face it, matters more than ever, while Red Magic just goes all in on a massive battery and an actual physical cooling fan. So here's the key takeaway. Both phones are converging on raw power, but they're diverging on how they optimize that power. Samsung is tuning everything for incredible camera performance and on-device AI. The Red Magic phone, though, it's all about sustained performance, keeping those frame rates cranked to the max for hours without overheating. We're talking gaming at full throttle for 2 hours, while a typical flagship might start to throttle down after just 45 minutes. And this just brilliantly shows that innovation isn't just happening in one lane. We're seeing these premium book-style foldables like the Motorola Razr Fold, some wild modular concepts from Tecno that let you physically snap on accessories, and even the Honor RoboPhone, which has a tiny little arm that unfolds to act as a camera gimbal. I mean, come on, the entire mobile landscape is transforming. But what's powering all these amazing devices? Let's peel back a layer and go deeper, from the phones themselves to the tiny silicon engines that make them tick. All that AI, all that photography, all that gaming performance, it all runs on semiconductors. And that industry is in the middle of a massive, massive transformation. The scale here is just staggering. The global semiconductor market is projected to hit nearly $1 trillion in 2026. This isn't just some normal market cycle. It's a huge structural expansion being driven by one thing above all else.
And that one thing? It's artificial intelligence. The industry is literally splitting into a two-speed market. You have traditional chips, which are seeing pretty modest kind of volatile growth, but AI-driven chips, they're just exploding, with growth rates hitting 30%. This is what's fueling that nearly $1 trillion market. And this AI boom is exactly why that new way of thinking, system-level performance, is so critical. Like we said, the old path of just shrinking transistors is hitting a wall, so the competitive advantage doesn't come from that alone anymore. Now it comes from mastering how the chips, the high-bandwidth memory, and advanced 3D packaging all work together in perfect harmony. Performance is about the entire system, not just one little component. But this silicon boom, it comes at a price. A single advanced chip factory can use as much electricity as a small city. All of this new computing power requires a staggering amount of energy, which connects us to the next critical layer of our story, the power grid. So how is the energy industry responding? Well, it's a three-pronged strategy. First, they are accelerating the rollout of solar panels paired with battery storage to meet the crazy demand from data centers.
Second, they're using AI itself to make the grid smarter and more efficient. And third, they're building more resilient supply chains by bringing manufacturing back home and investing heavily in recycling.
This brings us to a really powerful idea for 2026. The challenge isn't really about inventing more new climate tech anymore. For the most part, we have a lot of the solutions we need. The real challenge has shifted to execution, deploying the technologies we already have, like solar, storage, and green hydrogen, at a truly massive scale.
Okay, so we've got powerful new devices, running on powerful new chips, powered by a transforming energy grid. But all of this creates and processes an unprecedented amount of data, which brings us to our final and maybe the most important question. How do we keep it all safe?
Every single piece of this new technological foundation, from your phone to the data center to the power grid, it all relies on encryption. But the encryption we've used for decades is facing an existential threat from the coming age of quantum computing. The solution is a brand new type of security called post-quantum cryptography, or PQC. The easiest way to think about it is like creating new kinds of digital locks that are so incredibly complex, they're safe from both the computers we have today and the super powerful quantum computers of the future.
And the threat isn't some far-off sci-fi concept, it is happening right now. Adversaries are actively stealing and storing massive amounts of encrypted data today, betting that in a few years they'll have a quantum computer powerful enough to break it all. This is what's known as a harvest now, decrypt later attack. Thankfully, the world's best cryptographers saw this coming. The effort has been led by the U.S. National Institute of Standards and Technology, or NIST. They're the government body that sets the gold standard for this stuff. In fact, 2026 marks the 10th anniversary of their project to create quantum-resistant encryption. After a decade of hard work, the first official standards were finally locked in 2024, kicking off a global transition that the U.S. government hopes to complete by 2035.
And here they are, our new digital shields. Now, you don't need to memorize the names, but the key thing to understand is that they're built on entirely new kinds of math, things like lattice-based and hash-based cryptography. These are complex mathematical problems that we're pretty confident even a powerful quantum computer won't be able to solve.
So let's pull all these different threads together. When you really look at these trends, you see they aren't happening in isolation. Not at all. They are deeply, fundamentally interconnected.
Think about it like this. The amazing new AI features in your phone are only possible because of that new generation of AI chips. Those chips, in turn, create so much demand that they're accelerating the green energy revolution. And all of the valuable data created by this entire ecosystem has to be protected by a new class of post-quantum security. See, it's one single, interconnected story.
So, the most important point is this. 2026 is less about shiny new gadgets and much more about the quiet, difficult work of building an entirely new foundation for our digital world. The innovation phase is giving way to the age of execution. The blueprints are here. The only question is, are we ready to build?